Alright, so number 98 says simplify in each and state the excluded values. So what we want to do in both the numerator and denominator is factor as much as we can. I noticed that this has a 2 in the front, so if each of these are even, then I can factor it out, and they are. So I'm going to factor out a 2, and they, in fact, all have at least 2 r's in them. So I'm going to factor out a 2r squared. And I'm left with r squared plus 2r minus 15. In the denominator, I can factor out an r, and I'm left with r squared plus 8r plus 15. So now what I want to do is factor these two quadratics. So I've got 2r squared, and I'm looking for the factors of negative 15 that add up to 2. So positive 5 and, oop, just kidding, r. And negative 3. And the denominator, I'm looking for factors of 15 that add up to 8, which are positive 5 and positive 3. So, as far as simplifying goes, well, first let me state the excluded values. What r cannot equal is 0, anything that makes the denominator 0. 0, negative 5, and negative 3. So those are my excluded values. But then as far as simplifying goes, I can simplify out an r plus 5 and 1 r from the top and from the bottom, meaning my answer is 2r times r plus 3, or 2r squared minus 6r, divided by just r plus 3. See ya! Which means this is my answer. Number 99. Can't stay? Well, if you can come back. Well, if you hurry, you'll be back for at least half of it. Okay, so number 99. I want to factor out the common factor. They're each even, so I'm going to divide out a 2, and they each have an n in them. So I'm going to factor out an n, and I'm left with n squared plus 7n plus 10. Ooh. And then in the denominator, I can factor out a 4, and I'm left with n plus 2. So here I'm going to factor as much as I can, n plus the factors of 10 that add up to 7 are 5 and 2. 4n plus 2. And as far as things I can simplify out, we've got an n plus 2 on the top. Oh, just kidding. I need to make sure and state n cannot equal. Can you come back at the end of, or do you got? But for this last 2 pages, or did you get that Monday?
I did it.
Oh yeah, that's right. You had the end done.
Is it fine if I take pictures?
Yeah, sure.
I searched mine.
Okay, good. I'm glad. Okay, so n cannot equal negative 2 because of the denominator. Want anything that would make the denominator equal 0. So we can cancel those out, and then 2 and 2, so 2 divided by 4 is 1/2. So I'm left with n times n plus 5 in the numerator, or n squared plus 5n. And I'm left with 2 in the denominator. So this is my answer. And then number 100 says perform the indicated operation and simplify. So in order to add 2 fractions, you have to have a common denominator. What I want to do is I want to factor out any common factors in this denominator, 2n, and I'm left with n plus 2. So in fact, these both have a 2n in them already, which means the only thing I need to make them have a common denominator is to multiply this by n plus 2. So n plus 2. So I'm really dealing with 5n plus 10 plus n plus 6 divided by the common denominator, 2n times n plus 2, or 2n squared plus 4n. So the final answer, 6n plus 16 over 2n squared plus 4n. Oh, well, just kidding. They can all divide by 2, so I should do that. 3n plus 8 over n squared plus 2. There we go. Okay, number 101. I'm trying to subtract these two, and right now I'm looking at their denominators. They do not have anything in common, n plus 3 versus 4. So I'm going to multiply the denominator, this one by 4. So I'm going to multiply the numerator by 4. And on this one, I'm going to multiply by m plus 3. So I've got 4m minus 12. And then now I'm going to distribute a negative 4m. So minus 4m squared minus 12m. Over the common denominator, 4 times m plus 3. So let's combine like terms. I've got negative 4m squared minus 8m minus 12 over the common denominator, 4m plus 12. And that is my final answer. Oh, I don't even know if you can see all that. Could y'all see all that or not? I know, but could you see it when I was doing it?
Yeah.
Okay. I didn't know if I moved it out of the way. Okay. So on number 102. So 100 and 101, you're adding and subtracting, which means you have to have a common denominator. But on 102, you are multiplying. You do not need a common denominator when multiplying. I'm saying it like that because so many people do that, and that's just ridiculous. So in order to, now I could multiply all of this times all of this and this times all of that. That's not the goal. The goal is to simplify if possible. So I want to factor out as much as I can, see if anything simplifies. I'm going to factor out an 8 from this numerator, and I'm left with x plus 6. 9x doesn't factor, so I'll leave it like that. I'm going to factor out a 2 and an x from this one, leaving me with x minus 2, and then I'm going to factor this quadratic. The factors of negative 12 that add up to positive 4 are positive 6 and negative 2. So as far as simplifying goes, we've got an x minus 2 on the top and bottom, we've got an x plus 6 on the top and bottom, we've got an x on the top and bottom, and that's it. So my final answer is 16/9. On number 103, we are actually dividing the expressions. So when you divide, you have to multiply by the reciprocal. So I'm going to factor and rewrite at the same time. So I'm going to factor out a 9, and I'm left with m plus 7. And then in the denominator, I've got a 9 times. And so what I'm going to do is this one is going to go on the top. The factors of 32 that add up to negative 12, 8 and 4, m minus 8 and m minus 4. And then this will go in the denominator. I need the factors of negative 16 that add up to negative 6. And you've got m minus 8 and m plus 2. So as far as simplifying goes, m minus 8s can go away, the 9s can go away, and that's it, yeah? So I'm going to multiply those out in the top. M squared minus 4m plus 7m is plus 3m, and then minus 28 divided by m plus 2. And that is my final answer. Okay. So number 104. So 104 has a fraction divided by another fraction. What I want to do is factor and change that to multiplication. So let's start off. I'm going to factor this one right here. So this is going to go in the top spot. The factors of negative 80 that add up to negative 2 are negative 10 and positive 8. And we're going to be working, right? Okay. So the denominator right here in the numerator, I can factor out an x, and then I'm going to factor the quadratic. So I need the factors of negative 50 to add up to 5, so I'm thinking positive 10 and negative 5. Yeah? Alright, now we're going to multiply. And we're dividing with this fraction, which means this one is going to go to the numerator. Okay, I'm going to factor out a 3 and an x, and I'm going to be left with x minus 5. And the numerator of the denominator is going to go to the denominator of the second one. So this is going to go right here. Okay. I'm going to factor a negative out and make this x squared minus 2x minus 80 so that I don't have to deal with having a negative quadratic. So I'm going to put the negative in front and then the two factors. So we're looking at factors of negative 80 that add up to 2. In fact, it's just right there. So it is going to be the same thing, x minus 10 and x plus 8. All right, so now I need to simplify. I have got, let's see, an x minus 5, an x minus 5, an x minus 10 and an x plus 8, an x minus 10 and an x plus 8. I've got a single x here and a single x there. So the only thing I'm left with in the numerator is a 3, and the stuff in the denominator, I've got a negative and an x plus 10. I want to float the negative to the top and put x plus 10 down here, and that is my answer. All right, number 105. So 105, you want to simplify the fractions in the denominator so you have a single fraction. And the only way you can add two fractions is if you have a common denominator. So I'm going to multiply this one. They have nothing in common right now. I'm going to multiply this one on top and bottom by x squared and this one by 3. So now they have both 3x squared in the denominator. So I'm going to rewrite this. This is 4 over 1 over, so I'm going to rewrite 4 as a fraction, over x squared plus 9 over the common denominator, 3x squared. So once you have a common denominator, you can just write it as a single fraction. What you need. And then also, we've got a fraction divided by another fraction, so I'm going to write the first fraction, 4 over 1 times, and flip that. 3x squared over x squared plus 9, which leaves me with 12x squared over x squared plus 9, because nothing simplifies out. And there you go. Oh, too bad. Oh, sorry. So yeah, if you have addition or subtraction of fractions, and within a fraction, you need to combine those first, and then you can flip and multiply. All right, number 106. Again, we have two fractions in the denominator. However, they both have a factor of 2 in the denominator. This is 2 times x, so I really only need to multiply this one by x. So I've got 2 over 1 divided by x squared, and so we're going to do common denominator, 2x, right? I'm going to distribute this minus, okay? So I'm subtracting this whole fraction, so I'm going to say minus x, but then plus 1, all right? Which means when I multiply, or when I deal with dividing by a fraction, I'm going to say 2 over 1 times 2x, flip this, put this in the denominator, x squared minus x plus 1. So final answer is going to be 4x over x squared minus x plus 1. And there you go. Alright, so 107. This time you got actually two fractions in the top and two fractions in the bottom, which means this is even more fun than the ones before. So this denominator has 3a plus 5, this denominator has an a. A is not a factor of this one right here, so they need each other. So I'm going to multiply this one by a on top and bottom, and this one by 3a plus 5 on top and bottom. It's going to be a little bit more involved than the last one. This one is a over 1, so the common denominator can be 3, so we're just going to multiply top and bottom by 3. So let's start talking about this. The numerator is going to be, this is 4a, minus, let's talk about this. I'm going to put parentheses and multiply all this out, because what people are probably going to do is forget to distribute a parentheses, right, the negative right here. So I've got 3a squared from that, plus 5a plus 6a, which is plus 11a, and then plus 10. So I've got 4a minus 3a squared minus 11a minus 10 when I distribute this minus sign. So I've got negative 3a squared I've got 4a minus 11a, which is negative 7a, and then minus 10 over our common denominator of a times 3a plus 5 divided by 5a plus 3a, which is 8a over 3. Okay, so I've got negative 3a squared minus 7a minus 10 over a times 3a plus 5 times, flip this fraction, 3 over 8a. I don't think anything is going to simplify out, so final answer is going to be negative 9. So I'm going to multiply 3 times all of this. Negative 9a squared minus 21a minus 30. And my denominator is going to be 8a times a, which is 8a squared, times 3a plus 5. So 8a squared distributed. It's going to be 24a cubed plus 40a squared. You do not have to multiply that out in the denominator, but why not? We're there. Okay, numbers 108 and 109 have to do with the reference triangles, so plotting the point and then finding all six trig ratios. So let's graph that real quick. The point 5, negative 6 is in the fourth quadrant, so I'm just going to draw the fourth quadrant real quick. So if we go out 5 and down negative 6, then you've got this triangle right here. We're going to let, we went to the right 5 and we went down 6, and so I need to know my hypotenuse. So I'm going to do the Pythagorean theorem right quick. So a squared, which is 25, plus b squared, which is 36, equals c squared. So take the square root, and that is, what, 61? The square root of 61? Is 61 prime, or is that divided by? Okay. So then I need sine of the angle, cosine, tangent, cosecant, secant, and cotangent. Alright, sine is opposite over hypotenuse, so opposite over hypotenuse. I could write negative 6 over the square root of 61, but I know I'm going to have to rationalize by multiplying top and bottom by square root of 61, so it is negative 6 square roots of 61 over 61. Now, I got this from flipping this, which means cosecant is just hypotenuse over opposite. So square root of 61 over negative 6 is the negative square root of 61 over 6. Cosine is adjacent over hypotenuse, so that is 5 over the square root of 61. Same thing, we're going to rationalize 5 square roots of 61 over 61. And then to flip it, I've got the square root of 61 over 5 for secant. And then tangent. Tangent is opposite over adjacent, so opposite over adjacent is negative 6 over 5, which means cotangent is adjacent over opposite, 5 over negative 6, or negative 5/6. Alright, number 109 is the point negative 8, 8, which is in quadrant 2. We're going left 8 and up 8, so I'm going to draw quadrant 2 right quick. If I go left 8 and up 8, well, that is technically 45, 45, 90. And I know that whatever the leg is, the hypotenuse is just the leg times the square root of 2, but I can prove that real quick. 8 squared plus negative 8 squared equals c squared. That's just 64 plus 64, which is 2 times 64. And the square root of 64 is 8, so it is 8 square roots of 2. Now, that being said, when I start doing all these ratios, you're going to find out that all the 8s are going to simplify out, so I might as well just have the square root of 2, 1, and negative 1. I'm going to use the 8s, but if you notice that you have a common factor, then you could just divide it all out. So sine of theta, cosine of theta, tangent of theta, cosecant, secant, and cotangent. Sine is opposite over hypotenuse. So opposite over hypotenuse is 8 divided by 8 square root of 2. 8 simplify out, so I've got 1 over the square root of 2. If I multiply top and bottom by square root of 2, then I've got square root of 2 over 2. So square root of 2 over 2. But remember that sine, it was 1 over the square root of 2. We just rationalized to get this, which means cosecant, I can just flip this fraction and say square root of 2 over 1, which is square root of 2. Cosine is adjacent over hypotenuse. The only difference between opposite over hypotenuse and adjacent is the adjacent is negative, so negative 8 divided by 8 square roots of 2. Those simplify down to 1 as well, so I might as well be dealing with negative 1 over the square root of 2 or negative square root of 2 over 2. And then this will just be negative square root of 2. And then tangent is opposite over adjacent. So if I do opposite over adjacent, I guess I should have labeled the angle that I'm dealing with. Opposite over adjacent, 8 divided by negative 8 is negative 1, and if I flip that, I still get negative 1. And that is the end of page 12.